Okay, it is now time for us to conclude this tutorial. In this talk, we present you this new learning paradigm, which we call learning by exploration, which aims at closing the loop on top of this traditional supervised machine learning pipeline. That is, allow the machine to explore the space, to actively improve itself. And the central theme of this learning by exploration paradigm is efficient exploration, which we broadly covered various types of solutions from classical exploration strategies to the most recent work that focus more on the realistic, real-world, complicated learning environment. But we should note, this should never be the end of this study. Actually, it should be the beginning of it, because we still have many unsolved open problems. For example, throughout this tutorial, most of the solutions we present for contextual bandits focusing on linear models, and maybe more specifically or more generally, generalized linear model. However, this is definitely not enough to cover all sorts of supervised machine learning methods we have learned, we have used in practice. You may already want to know, how do we handle deep models? Due to its great success in practice nowadays, what is the most effective exploration strategy for deep neural networks? Unfortunately, we don't know yet. There is some recent effort try to combine the traditional exploration strategies, for example, upper confidence bound-based method for deep neural networks. Another open challenge in this direction of research is online deployment. Solutions in this family requires real-time updates, so the policy can fit to the environment, reduce the regrets. However, real-time machine learning is non-trivial at all. It not only requires correct implementation of the algorithm, but also the support from infrastructure. We have some recent work to try to address this challenge, focusing on specific exploration strategies, for example, upper confidence bound-based exploration, and very specific reward models, such as linear models. So this is still a quite challenging open problem for us to solve. The next thing is, most of the algorithms we have discussed in this tutorial assume a benign learning environment. That is, the users are faithful and they are cooperative. However, there will be a lot of real-world challenges like adversarial attacks or learning under this adversarial context. And the problem becomes even more serious under high-stake application areas like healthcare. What if we have malicious users? They try to attack the system, try to learn some private information of the users, and such privacy breach under extraction attack has been reported, and people know the existence of them. Then how can we handle it? How can we harden the algorithm to fight against such attacks? And we believe the exploration that is needed or that is proposed in this paradigm of learning reconciles or has the potential to reconcile the need for learning and the need for privacy protection. Why? Let's take differential privacy as an example. In order to achieve differential privacy, we are required to inject random noise, which happens to be the perturbation we need for exploration. So can we design such an exploration mechanism that achieve both the need for learning and the need for privacy protection? That is one stone, two birds. In addition, the attackers might not only want to steal information from the learning process, but also interfere. For example, launch this manipulation attack to affect the learning outcome, to control the system. How do we handle it? Also, we believe the answer is calibrated exploration, because the randomness in exploration can harden the model against adversary. And we can also leverage the dependency structure among the users to improve the hardness or the robustness of the model. Last but not least, we believe that exploration should never be a one-set effort only on the machine, especially in the scenarios where the machines are learning by interacting with humans. It should be a cooperative game. That is, machines should actively or even proactively prompt the users for feedback so they can achieve better results in the long term. For example, in a recommender system, can systems explain the result to the users? Why at this moment we take this action? Maybe this is just for short-term exploration, while for the long-term return. In this case, the users are incentivized to cooperate to finish this exploration together with the machine. We wish this is not the end of the tutorial, but just the beginning of it. And then we also hope you're getting as excited as we are about this domain. We look forward to working with you to create more exciting and new techniques for learning by exploration. In the end, we would like to thank our collaborators and our funding agencies. Now we have time to take your questions. Thank you.